statistics. So up to 8th class it is data handling. So how to handle the data, how we divide the data, and which operations we can do on the given data. So we learned up to 8th class. In 9th class and 10th class, so this will become statistics. So statistics is very important. So statistical tools are useful in so census, in finding records like that. So before going to discuss statistics, so data, what is data? The collection of information is called data. The collection of information. The collection of information is called data. So if the data had been collected, either yourself or somebody else, whatever it is. So if you have some data, if you have some information, it is called data. Okay, the collection of the information is called data. Okay, now there are two types of data. So there are two types of data. One is primary data and secondary data. Two types of data, primary data and secondary data. Primary data is nothing but the data had been collected by ourselves. So data is collecting by ourselves. So the information is called primary data. Are known sources. Either we are collecting by ourselves, we collect a collection by ourselves, or we are the data had been collected by known sources. So the person who we know, so we are gathering the information from them. That is also primary data. So the data had been collected by ourselves or known sources is called primary data. The data had been collected by ourselves or known sources is called primary data. Next, secondary data. Secondary data. So secondary data is nothing but so we don't know the information, whether the information is correct or not, but we are simply taking from old records or registers like that. So simply we are taking the information from unknown sources, that is called secondary data. So the information, so the data is collected by unknown sources like registers or old records. Then such data is called secondary data. So the data collected by observer is primary data. The data is collected with unknown sources is called secondary data. Okay. And next, tally marks. So what is the purpose of tally marks? So if the data is bigger, to convert, so to convert the data into simple way, we use tally marks. Tally marks is simply used to count the frequency. So to calculate frequency, we use tally marks. So to calculate the frequency, we are using tally marks. Next, so after this, so frequency distribution table. Frequency distribution table. So, if the information or data is distributed to the observations corresponding frequencies, such a table is called frequency distribution table. So, if the data had been distributed to all the observations, then observation corresponding frequency table is called frequency distribution table. Distribution table. So, example. So, this is observation exercise. This is frequency exercise. So, like this table is called. So, here the observation, how many times it is occurred. So, this is called a frequency distribution table. Next, grouped frequency distribution table. Grouped frequency distribution table. So, grouped frequency distribution table is nothing but so instead of observations, the large amount of data is to be divided into class intervals. The large amount of data will be distributed into class intervals, and so how many observations are within the class intervals are called frequency. Then class interval corresponding frequency table is called grouped frequency distribution table. So, grouped frequency distribution table, if the data had been distributed into the class intervals, into the class intervals, and corresponding frequencies, then the distributed table is called frequency distribution table. So, example. So, here it is class interval, here it is frequency. So, for example, here 1, 2, 3, 4, 5, 4, 3, 5, 2, 1. So, 1 came 4 times, 2 came 3 times, like that. So, these are the observation corresponding frequencies. So, here if we take 0 to 10, 10 to 20, 20 to 30, 30 to 40. So, these are the class intervals. So, 0 to 10, 5 members, 10 to 20, 12 members. So, this is 11 members, this is 4 members. So, this is called grouped frequency distribution table. Okay, next. Next one, measures of central tendency. So, measures of central tendency. So, measures of central tendencies are majorly three. The three measures of central tendencies are arithmetic mean, median, and mode. So, first, arithmetic mean. So, there are three types of measures of central tendencies. Okay, so first one, arithmetic mean. So arithmetic mean is nothing but some observations are given. So to find mean, we need to do sum and divide with its number of observations. So sum of observations by number of observations is called arithmetic mean. So simply, so the average of all observations is called arithmetic mean. The average of all observations is called arithmetic mean. So formula. So it is denoted with x bar, and x bar is equal to sum of observations by number of observations. Sum of observations by number of observations. So x bar equal to sigma fi xi by sigma fi, or sigma fi xi by capital A. So capital A means nothing but total frequency. Here capital A is total frequency, xi are observations, and fi is frequency of observation xi. So fi is the frequency of observation xi. Okay. Now, so next one, after this, so median. So median is nothing but so middle one. When it is middle one, if you write all the observations in either ascending order or descending order, the exact middle one is called median. If there exists two middle, average should be median. Okay, so if we arrange all the observations in either ascending or descending order, then if there exists only one middle term, it is median term, then it is median. Or if there exists two middle terms, then so the average of those two middle terms is called median. Okay, so if we write all the observations in either ascending order or descending order, if there exists only one middle term, that middle term is called median. If there exist two middle terms, so the average of those two middle terms is called median. Okay, so next mode. So mode is nothing but if among all the observations, which one is more repeated is called mode. Which observation is more repeated, more frequently occurred is called mode. So, for example, none of the observation is repeated, there won't be any mode. If two or more observations are repeated more times and equal number of times, then so how many are existed So those all are modes. So the most frequently occurred observation is called the most frequently occurred observation is called mode. Okay. So if none of the observation is repeated, then there is no mode. If two or more observations repeated more and equal number of times, those all are modes. So if two observations are repeated more times and equal times, so then the data is called bimodal data. Okay, so this is about mode. Next, range. So range is nothing but in the given data, the difference between maximum and minimum value is called mode. So the difference of maximum and minimum value of the given data is called range. The difference between maximum and minimum value is called range. Next, cumulative frequency. So cumulative frequency is nothing but so till that observation, if we write in ascending order or descending order, if the number will come till the observation, how many observations are there, it is called cumulative frequency. So if the data is written, is arranged in either ascending or descending order, either in ascending or descending order, then if the data is arranged in ascending or descending order, then the number of observations till that observation is called cumulative frequency. Okay, so this is the information. So these properties are very exercise 14.1. So before doing these problems, in this 14.1 exercise we are doing the problems on arithmetic mean. So mean formulas I want to write. So x bar equal to sigma fi xi by capital N or sigma fi. X bar. Next, deviation method. So this is direct method. Deviation method, x bar equal to sigma fi, not a plus sigma fi di by sigma fi. So this is a deviation method. So here A is assumed mean, di is the deviation. Di equal to xi minus a. So Fi is the frequency of x. Fi is the frequency of x. This is deviation method, direct method. Next, step deviation method. Step deviation method. So step deviation method is x bar equal to a plus sigma Fi ui by sigma Fi into h. So a is assumed mean ui step deviation. So ui equal to xi minus a by h. Xi minus a by h. H is class size. H is class size. For grouped frequency distribution, we need to apply these formulas. Okay. Now, so that we may problem in whatever the method we can do in all the methods. So direct method is useful when the problems are numerically somewhat lesser values, small values. So step deviation method and deviation method are useful to if the quantities are bigger. By using this step deviation method, so we can easily convert the quantities into smaller one. Then we can easily do the problems. So one problem we will do. Exercise 14.1. First question. A survey was conducted by a group of students. As a part of their environment, as a part of their environment, awareness program in which they collected the following data. They collected the following data regarding the number of plants. In 20 houses in a locality. In 20 houses in a locality. Find mean number of plants per house. Find mean number of plants in a house. Okay. So number of plants, number of houses. Number of plants and number of houses. 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14. 1 to 1, 5, 6. 1 to 1, 5, 6, 2, 3. So this data is given, we need to find out mean. So a survey was conducted by a group of students as a part of the environment awareness program in which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of plants in a house. So about the plants it is given. How many plants average in a locality? Okay, in each house in the locality. So number of plants I am taking it is a class interval. Class interval. Next, this one frequency. So class intervals 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14. So this is class interval. Next, frequency 1, 2, 1, 5, 6, 2, 3. Next, so xi. What is xi? Xi is the class of average of these two. 0 plus 2, 2 by 2, 1. 2 plus 4, 6 by 2, 3. 4 plus 6, 10 by 2, 5. 6 plus 8, 14 by 2, 7. 18 by 2, 9. 22 by 2, 11. 26, 13. Okay. Now, so actually these are the smaller numbers. We are not required deviation and step deviation. We can easily multiply. Formula sigma fi xi by capital F. This is capital F. 3 plus 2, 5 plus 6, 11 plus 5, 16, 17 plus 2, 19 plus 1, 20. Actually, it is already given 20 houses. Okay. Now, multiply fi into xi. 1 into 1, 1. 2 into 3, 6. 1 into 5, 5. 5 into 7, 35. 6 into 9, 54. 1, 2 into 11, 22. 3 into 13, 39. Now we add. So this is fi xi sum. Okay, now 9 plus 2, 11 plus 4, 15 plus 5. 15 plus 5, 20, 25 plus 6. 25 plus 6, 31, 32. 3 plus 3, 6 plus 2, 8 plus 5, 13 plus 3, 60. 162. Now, so x bar equal to sigma fi xi by capital N or sigma fi. So 162 by 20 cancel with 2. 81. 81 by 10, 8. So mean equal to